Hello everyone. In this video we're going to be solving a nice polynomial equation. We have x cubed minus 3x equals 2. And I'll be presenting two methods. And let's start with the first method. For my first method, I'm going to use the cubic formula, and you can name it differently. You know, Cardano's formula, Tartaglia's formula, Ferrero's formula, so on and so forth. So many people are involved in this business. So let's just call it the cubic formula. There's a quadratic formula, as you know, negative b plus minus the square root of b squared minus 4ac divided by 2a. There's also a cubic formula. Instead of giving you a formula and just ask you to plug it in, I'm going to show you how the formula works. And we've used this before. But this is a really good example because you get the answer real quick. So here's how it goes. We're going to start with this identity, a plus b cubed. As you know, this can be written as a cubed plus b cubed plus 3ab multiplied by a plus b. Now I'm going to go ahead and isolate this. So let's write it as a plus b quantity cubed minus 3ab times a plus b equals a cubed plus b cubed. Now I want to write it this way because I can kind of make it look like a cubic equation, but of course it needs to be a reduced cubic, meaning that I should not have an x squared term. If you do have an x squared term, you can always get rid of it by using a linear substitution. So in this case, I want a plus b to be x. So my equation turns into something like this: x cubed minus 3ab times x equals a cubed plus b cubed. Now notice that my equation kind of looks like this, right? If you put those two together and think about it, I can really make my equation look like the first one. How? Well, you can do the following. I want negative 3ab to be negative 3, or 3ab to be equal to 3, and I want a cubed plus b cubed to equal 2. That implies ab equals 1 and a cubed plus b cubed equals 2. And guess what? That gives us a system. Is it a cubic system? No, it is a quadratic system. Let's see why. First of all, cube both sides in the first equation. And then from the second equation, isolate b cubed and write it as 2 minus a cubed. And then you can take this and plug in here, and you get a cubed times 2 minus a cubed equals 1, and then 2a cubed minus a to the 6 equals 1, and then a to the 6 minus 2a cubed plus 1 equals 0, so on and so forth. But come on, let's think about it for a minute. It's a lot easier than this, especially for this equation, because very easy to guess and check. Think about it. We're looking for two numbers whose product is 1, and the sum of the cubes of those numbers is equal to 2. So can't they be 1 and 1? And the answer is absolutely yes. They can be, and they are. So a equals 1, b equals 1 works. And even if you solve this equation by using another substitution, like set a cubed equal to c, you get c squared minus 2c plus 1, so on and so forth. It's just a matter of seeing or not seeing, to see or not to see. Okay, anyways, so this equation is to solve, and what did we say? A equals 1, b equals 1 works, and we define x to be a plus 1, a plus b, and that becomes 2. So x equals 2 works, which means we can go ahead and manipulate this equation. Let's go ahead and put everything on the same side. And then we're going to go ahead and, knowing that x equals 2 is a solution, we're going to manipulate this equation. And a lot of times people ask me, and I'm going to try to make a separate video on how this is done with polynomials. That's fairly easy. I know some people like long division. If you like it, be my guest. You can go ahead and divide this expression into x minus 2, so on and so forth, and you're going to get x squared, so on and so forth. You can do that, definitely. You can do synthetic division or Horner's method, anything you like. But I'm just going to use a manipulation because it's fun. So just keep in mind that x equals 2 is a solution. In other words, x minus 2 is a factor, because factor theorem says so. So how do you make x minus 2 is a factor? So think about it. You have an x cubed. If x minus 2 is a factor, then its multiples are also factors, right? Because if some number is a factor, its multiples are also the factors, right? Well, actually, that's not necessarily true, but hopefully you get the idea. So here's what I'm trying to say. If x minus 2 is a factor, I can multiply it by x squared. That's going to give me x cubed minus 2x squared. So now x minus 2 is gonna be a factor of this. Make sense? Okay, good. So that's what we're going to do. From x cubed, we're going to subtract 2x squared. So remember this. Reduce the degree and subtract 2 times the previous power. Make sense? Sort of. Okay. Now you're going to do the opposite here because you have to change the sign every time. But you have to double the coefficient because x minus 2 is a factor. So now this time plus 4x. And what is it going to be followed by? It's just going to have to be, by the way, I forgot, this is not 4x because we have to add 2x squared first. And then follow by minus 4x. Okay, I'm ahead of myself. Why? Because we just subtracted 2x squared, we have to add it. Okay, so if that was confusing, let's start over. So here's what I did. I want x minus 2 to be a factor, so I'm going to subtract 2x squared and add 2x squared. Great, now x minus 2 is a factor. But I can't just do this. Well, I can do it, but then I have to continue with negative 3x, but I don't want it. I want minus 4x. Why? Because again, x minus 2 is a factor. Check it out. But I have negative 3x, so I have to add x to it, and then it'll be followed by the 2. That's the last term, and we're done. And x minus 2 again is a factor. Notice that this can be written as x squared times x minus 2, 2x times x minus 2, and 1 times x minus 2 equals 0. X minus 2 times x squared plus 2x plus 1 equals 0. From here we get x minus 2 times x plus 1 squared equals 0. And this gives us x equals 2 and x equals negative 1. Those are going to be all the solutions. Let's go ahead and take a look at the second method, and we're going to look at the graph at the end. Okay, here's how the second method goes. We have x cubed minus 3x minus 2. Notice that the sum of the odd coefficients, like 1 plus negative 3, is the same as the even coefficients, which means x equals negative 1 is a solution. Remember, we talked about this trick before. So we can go ahead and make negative x minus x equals negative 1 a solution. In other words, we can write it like x cubed plus x squared minus x squared minus x minus 2x minus 2. Because this gives us x plus 1 is a factor. X squared times x plus 1 minus x times x plus 1 minus 2 times x plus 1 gives us x plus 1 times x squared minus x minus 2. And now x squared minus x minus 2 is factorable into x minus 1 and x plus 1 and x minus 2. And this gives us x plus 1 squared times x minus 2 equals 0. And that is negative 1 and 2 are going to be the solutions as before. And here's the graph of our function, x cubed minus 3x minus 2, and the two solutions. Notice that it has a double solution, so it's tangent to the x-axis. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.